My name is Toby. I'm a PhD student, and as a PhD student we have to do teaching in Germany. So I'm involved in algorithm and data structure courses, and by doing programming competition I got involved into the development of DOMJudge, and so we combined the two things and use DOMJudge now in our algorithm and data structure courses. My plan for the talk is I explain with a few slides how DOMJudge works, what the features are, and then on two courses how we use it at our university. So first, DOMJudge in a nutshell is we have very simple web interfaces for the teams, the jury, and the general public. That is all based on the standard LAMP stack, so you need only a Linux machine with Apache, MySQL, and PHP. And we try to keep it as simple as possible wherever possible. So it's all kept very simple. And DOMJudge supports distributed judging, so it's scalable. If the judging power does not, if you don't have enough judging power, just add another machine, and it's fully automated, and it's secure in the way that we have a well-tested sandbox solution, so there's no harm to be expected by the students. And DOMJudge offers a modular system for extension, so you can easily plug in another language or validator or a runner program for other kinds of problems. So DOMJudge is used by several ICPC regionals all over the world. We have been used as a backup system the last two World Finals, and of course by many sub-regional contests, local contests. But DOMJudge is also used as a courseware. Initially DOMJudge was designed for programming contests, but we now have an online judge branch. I will tell more about that later. And DOMJudge is open source, and we do active development, so contributions are welcome. If you have a feature request, that's also a contribution. If you have a patch, send us the patch. If you have an idea for something we could do, send us the idea. So what are the requirements? You need one server. Usually we have one server for the web interface and the databases. You need some judge hosts. One is enough, but yeah, for this regional we had more than enough judge hosts, and of course you need some workstations. Yeah, balloons. You need balloons. That gives so many nice pictures, the balloons. And I show you some screenshots of DOMJudge. So you have a public scoreboard that's from the last World Finals. As you can expect, the green cells illustrate the solved problems, red cells illustrate tried but unsolved problems, and blue cells are pending. So that's the screenshots from the freeze. And you can mark your favorite teams, and their score row goes to the top, so you can easily follow your team during a competition. For the teams, we have one single web page with all the important information. So the score row from the scoreboard is copied out of the scoreboard and illustrated here. All the old submissions you can submit here, new code, and here you see the clarifications. Initially we had 5 or 6 team pages, but teams told us, hey, we have to click so much around, so we consolidated all of this to one single page. So you have this page, and if you want to, you can view the full scoreboard on an extra page. On the jury side, the most important page is this one that shows a single submission. DOMJudge supports multiple test files per problem, so you see that this problem has many, many test files, and the submission failed on exactly one of the test files. And what you can see is that we show the relevant file here, so you can download the data. And I don't know if you can see it, but we support images for test files. So you can easily, for geometry problems like this one, you can easily spot what is the problem, why is this test case different from the other test cases, why is this submission failing on that test case. And then we have here the difference between the reference output and the team output. I don't think you can see the color, but we have a LCS. We compute the LCS between those two outputs and color the output accordingly. The jury supports fully automated judging, or if you want to, you can disable it and set it to manual verification. You can view, edit, and resubmit code. So if you think you found a bug in the student's code, say it's the wrong data type or so, you can just change the code and resubmit under your own user and check if you're right, if that's the problem of the code and nothing else. And you can then view the difference to the previous submission or to the original code, both in terms of source code, also in this overview of test files. So you can easily check what changed to the last submission or what changed during resubmit. You can claim submissions. Claiming submissions makes especially sense if you have a distributed jury. For example, we have this in the German sub-regional. Usually we have jury members at 5 universities or so. So you can claim the submission and say, I take care of that submission. I verify that's correct, and we don't have a technical issue here or a wrong test case. That can happen all the time. And if that happens, you need the rejudge feature. You can rejudge one single submission or more than one submission based on a filter mechanism. And we recently introduced rejudgings that don't apply automatically. So if you found a mistake in your test data, or for example, the validator precision, you change that and select the problem for rejudging, wait until the rejudging finishes, and it shows you a table like this, and you see there are 4 submissions who was wrong answer before and now are accepted. They are also listed here. You can view them in detail and check if your change in the validator precision solved the problem or not, and then you can apply or cancel the rejudging. That helps very much to see that you're doing the right thing. Domjudge supports or switched to the problem archive org format that the Catus also uses. We used a slightly different format before, but we decided to use the same format to standardize a bit so we can exchange problems more easily. The format is basically a convention. So you have a directory layout, and in the directory layout you place the files, and the directory is named submissions accepted and submissions wrong answer and data sample and data secret and so on, and zip it up and upload it into Domjudge or wherever. So you can import test cases, jury submissions, validators, all stuff you need to prepare a problem or a contest into Domjudge. And the jury submissions are judged during import, so you can verify that they work as expected. For the verification, we add those annotations, expected results to each submission. So if you expect a submission to be a wrong answer, it gets an annotation if it's not already present in the source code. And you can verify with one button click if they are all correct. So we have 2 submissions here with the annotation which are not, which give not the correct result. So you can look into that, and you have to fix your setup maybe. Sometimes you did the configuration wrong. DOMJudge comes with a separate tool, check test data. Check test data is a tool to verify the syntactic correctness of jury test data. So you write input specification in a meta language and use it for verification. That helps a lot to increase the quality of your test data. So one example is in the input specification in the problem statement, often people say the number is positive, and then they have test data with 0 in the file. So 0 is non-negative, but is not positive. So we caught many bugs in our test data using check test data, and I recommend you using it. That's one example for test data. So you have to specify which tokens are in the input. For example, you expect one integer from 0 to 10 and store the result in a variable, then space, another integer, and so on. And you can add asserts to the code. So you say at least one of these variables has to be positive or non-zero. You have loops and so on. So I think we try to support as much problems as possible, and for at least for the last 2 NWorks we supported 9 of 10 problems. So there's always one problem where you have to add additional checks over check test data, but that's the usual case is you only have to verify the syntactic correctness. Sometimes we also use it for syntactic output validation. That especially makes sense if you have an output validator where you check, for example, if the output of the student submission is a tree. And you expect a specific format. And you check first the specific format syntactically. So in your output validator, you only have to semantically check, is it really a tree? So you separate these 2 concerns. And we also integrated random test data generation in check test data. So if we have a formal specification of the check test data, it's easy to generate data based on that specification. And for many problems that works out quite well. Of course, you have to generate also test data manually for corner cases, edge cases, and so on. And I also recommend using the problem tools from Caddis that are tools to validate and verify the contents of the problem archive.org format. That allows you to run all the submissions and check if they give the result, and also determine a good time limit. So you just add a bunch of accepted solutions, a bunch of time limit solutions in each language, and it says you, hey, a good time limit is this one because it's between those 2. That's also open source on GitHub. I have the URL on a slide later. Use it to increase the quality of your problems, and the good thing is it integrates with check test data, so you can put your check test data files into problem tools, and your test data is checked, and it integrates with DOMJudge because we are using the same format. So use these tools to increase the quality of your problems. DOMJudge can also import and export stuff next to problems, so we can import teams, team categories, and so on via TSV import. We can also export stuff via TSV, but we usually use our REST API for that. So on our REST API, you can query almost anything. you have to authenticate as a user, and giving your rights, you may get different things. So as a public user, you won't get access to the submissions, but as a jury user, you will. And you can use that, for example, for certificate generation. That's what we use it for. And yeah, it's quite nice to have the last feature on the slide. That's the import and export to the Baylor system. So you generate a web services token on the Baylor side, add the credentials here, the contest ID and the token, and fetch the teams from the Baylor side. You can do that multiple times, so it updates your local data and changes team names or contestants in a team or stuff like that. And you can also, after contest, upload the standings to Baylor. So that's only 2 clicks, and you're full set to go. DomJudge is highly configurable. We have a bunch of configuration options on this website, but we have sensible defaults. So if you have a common usual setting, you can use our defaults, but if you want to, you can play around with the configuration. It's almost anything is in the database stored and accessible through the web interface. So you don't have to SSH into every judge daemon to change the configuration or stuff like that. So, for example, you can enable lazy judging. Lazy judging means it stops on the first error. So you don't need so much judging power, but you lose a bit of information for the jury. So, for example, the submission I showed earlier, it failed somewhere in the middle, and we wouldn't know the result of the rest of the test data if we stopped on the first error. So change it depending on your needs. Now I explain, switch a bit, how we use DomJudge in our courses. One of our courses is named Hello World for advanced students. So we don't want the students to write as simple programs as Hello World, but bit more difficult programs. In a nutshell, that's a course for students in the 2nd year. It covers advanced algorithms and data structures. Each student gives a talk of approximately 60 minutes, and we have related to each talk, we have categories, and for each category, we have 6 problems roundabout, and students have to solve 30 problems in the whole semester, but at least one of each category. So they cannot skip number theory because they don't like it. So they have to solve at least one problem in each category and 30 problems at all. And that problem solving doesn't influence the grade. It is mandatory to get the credits, but the grade solely comes from the talk. So how did the talk go, and how well did they explain the algorithms? After each talk, we have problem discussions in teams of 3. So I bring problems to the class, and one of the problems is the one of the 6 problems. So they already discussed the problems they have to solve. And 2 problems are from UVA or Topcoder or Codeforces. So students are motivated to see there are other online judges around where I can practice and where I can find nice problems. Yeah, their topics, I think I can skip that slide. That is probably the same everywhere, advanced algorithms. So in the early years, we have used UVA in programming challenges, and we queried the HTML pages to generate an overview table. So if you have a spike in your network, that was us. So we had these tables, but that had some drawbacks. Some students didn't like public results. So even that they used a nickname on UVA, many people know that's he, and I used the same nickname for online gaming and stuff like that. So they didn't like that. Then Java was, at least at that time, it was hard to submit in Java and do all the things right with input and output and all the restrictions. And in our first semester, students learn Java. So that's the most important language. Usually they switch in the second semester to C++ at some point of time, but they start with Java. And we could not really help the students. So students tried 20 times to submit the same problem and told us the problem is so hard, I cannot solve it. And we didn't know what the exact problem is. We couldn't help them. And we also wanted to add extra problems. So we had a nice dynamic programming problem in our local contest. We want to use it. And we want to use it for the course. So that's why we decided to create an online judge branch of DomJudge. And we try to keep it the same as the master branch as much as possible, so we don't have to maintain too much different code. So we have a minimal modified dashboard. The main difference is that all the lists are collapsed by default. So if you have 500 submissions, you will not see anything. Also, scoreboard row doesn't make sense for 100 problems or so. So we have bit minor modifications here. One modification which helped a lot is that we made the sample input and output public. So that's the difference is that we provided the files here. So students didn't have to copy it from the PDF or stuff like that. They could download the files, and that made it much easier for them to try their submissions locally before submitting them. Even then, we publish the results. So students can see the same outputs as we can see on the jury side for the samples input and output. That made sense because we are not using same compiler versions or same architecture. So we switched to 64 bits just a year ago or so, and most students had 64 bits. So that made many problems, and they could see at the sample input, hey, that is my problem. It's already wrong on the sample input. Then we added statistics, so you can see, you can filter by category, say dynamic programming, and see, okay, most dynamic programming is solved in C++, some in Java, and yeah, most results are wrong answer. You can even sort it by ratio of solved versus unsolved, and find out which problems are the easiest in that category, so to start with that. We had to add a FAO-specific authentication module. We didn't want students to have another account, so we had our courseware system, and we added authentication against that. So students didn't have to remember another password. The online judge is open to every student, so it's not only open to students of the course. And we see that the weeks before our local contests or the sub-regionals, the participation increases. So that also helps a lot, so we can help the students and say see what they are doing wrong and help them. But the main difference is students are allowed to view correct solutions from other students once they got a correct on the same problem. That helps so much. So you can learn from other students how to code smart and short solutions. You learn how to code more efficient solutions. So sometimes a problem is solvable in linear time, but we allowed students to solve it in n². So, but they see, hey, somebody else solved it in linear time. I tried in my own. And they also see how to code solutions in other languages. So there are problems that are much easier in some languages than in other languages. And so that feature helped a lot, and students made a lot of profit to learn from each other by viewing the source code. For us, we send us a half-daily digest every morning, every evening about all the submissions in the last 12 hours. So we quickly see when some student really tries to solve a problem and see, okay, he now has 10 submissions to the same problem. I really have to look into that submission. What is wrong? And so that helps us to react quickly and help the students. Most of the time we try to support the student by giving out test cases. Instead of saying you're using the wrong data type, we are hinting by try that test case, try to figure out what you're doing wrong. That test case is wrong in your code. And we have a dedicated IRC channel for our course, and we have almost 24/7 support in that channel. Not that I am doing the support, but there are students from earlier semesters in that channel. And so when a student comes in the channel and asks a question, there's almost for every problem, there are students that already solved that problem and are willing to help other people to solve the problem too. So that was also a good decision to open that IRC channel. So students at our university don't like Facebook and stuff like that, so they stick with IRC, and we decided, okay, let's use IRC for that. Then we have one student assistant, which does most of the work for us. So he looks into the submissions and check if there's something wrong with our system and stuff like that. And that student is much better in the next ICPC because he's looking at so much source code and he's trying to figure out what is the bug. And he's much quicker in finding bugs in source code from other contestants. So that helps a lot. Yeah, and last but not least, we have the AutoScore system. The AutoScore system is a tool that supports us for grading in our freshman course. So that's the basic algorithm and data structure course. And I start with explaining our constraints. As I told earlier, we have Java as a first programming language. The semester is around 14 weeks, or in 14 weeks we have exercises. They have to solve around 3 problems per week. Some in the beginning with pair programming. In the end, they have to solve everything on their own. And they have to get 60% of the points. So that's not a binary decision per exercise, 60% of the points to get the credits. And if they got the credits, they can take the exam. So that's a precondition. And we pay student assistants to evaluate the theory and the programming exercises. And for these student assistants, we had wages that were okay, but not that good, especially compared to industry. They can earn much more money there. So what takes most of their time is the evaluation of the programming code, not the theory exercises, but the program code takes most of the time. So some years ago, we decided to use JUnit as a tool to support the student assistance. So we wrote for each exercise, we wrote JUnit code to help them to find bugs quickly. So you can see this part of the code is correct. I only have to look in that method if something is wrong. But the quality of the JUnit test case varied a lot because there was no direct influence to grading, and we are all lazy people, so that varied a lot. So there was still a lot of manual work required. The motivation for our tool then was that in Germany we had student fees for a short time period, and after that we got less money than before that time. So we had also an increased number of students, and both together we had only two options, or two obvious options. We must increase the work for our student assistants or reduce the salary. Yeah, that's given the fact that it's not easy to find good student assistants. Already before we thought we have to do something about that. So what we do is we reduce the amount of work for student assistants by automation. How do we do that? Yeah, I love that light bulb. We already have a tool for that. We already use DomJudge in different contexts. And already DomJudge does automated evaluation of source code. So why don't we use that? There are some obvious drawbacks. One is here, it's either correct or wrong. That's a bit harsh for beginners. Let's have a look at another drawback is the input-output. So if you're starting to program, and your first programs or mathematic calculations or stuff like that, and you're trying to understand that opposed to a variable in mathematics, you can write a variable multiple times, and that's magic, then you struggle with writing I/O routines, and that's so hard for beginners. So we decided, hey, we already have JUnit, and we already have DomJudge, and let us combine those two into one system to get rid of the input and output and get rid of the binary decision of correct and wrong. So the question is, how do we have to improve JUnit from a support tool to a grading tool without the risk of this code? So yeah, every semester someone tries stuff like this. Yeah, and we need a sandbox. That's obvious. So luckily, DomJudge since version 4 supports the REST API, and the judge daemons and the main server communicate via the REST API. So what we did is we replaced the main server with our homebrewed courseware system and used the judge daemons because they are well-known, tested sandboxes, and they work. So it was quite easy to implement that part of the API that hands out submissions to judge and the test cases and so on. For the students, we had to increase the minimum set of requirements. So in earlier years, we had the requirement your code must compile. Now we had to say we have to execute your code with JUnit. It has to compile with our JUnit test case. So you have to fulfill some requirements, interfaces, so we can actually execute the JUnit test case. And we had to learn that we have to write much more precise specifications. As an example, I don't know if you can see it. We had this exercise where you have to code a fractal tree and we had a rather sloppy specification how to do that. And now we had to specify, if we want to judge that, we have to specify, start at the left side and then go def first and stuff like this. So we had to learn how to write specifications in a way that there are no ambiguities. We decided to hand out skeletons in the first weeks of the semester. So students only have to add code to methods. So the methods already existed with some return 0 or stuff like that. And add code into that. And later on, they have to implement against interfaces. So it was a bit more work for us, but much less work for the student assistants. Disadvantage of this is students didn't learn how to write a program from scratch. So we had some exercises during the semester where students had to write really from scratch, and we evaluated the exercise manually. So, like in ICPC, we have public versus secret test data. As I told earlier, exercises don't have to be perfect. They only have to get 60% of the points to pass the course. And many students got stuck and really tried to solve the problem until they get 100% correct. So we decided we hide the exact scores until the deadline and use it like sample cases in ICPC. That also gives us the chance to review the results and check if we catched every case, if there's something wrong, if students try to cheat in a way and catch all these cases automatically. That is a quite nice way in doing that. So we separated into two different JUnit classes. One is public, that also decreases the chance of misinterpretations on the student side. And we decided also to give hints into the public cases to corner cases. So in the beginning of the semester, students who passed the public cases almost passed all the secret test data, and later on we moved more stuff from public to secret to make it a bit harder. So the systems architecture is split up in three separate stages. In stage 0, we compile the source code from the students as it comes. So plain Java-C, all Java files, we don't run it. Second stage is we compile it with our public test case and execute the public JUnit test case. And the last stage is we compile and run both the public and the secret test case. The first two stages have preference, so if a submission comes in, it gets judged immediately, and later on, if the judge daemons are idle, they are judging the stage 2, because we will not show the result to the student at this time. So students get results in form of icons, and that helps also a lot. So the hourglass for your submission is queued, or we have an internal error that happens. That compile error in stage 0, you're doing it completely wrong. You submitted code that doesn't compile, even without JUnit test case. So you're really doing it completely wrong. For example, submitting class files instead of Java files that don't compile. And then the crossmark compile error in stage 1, so you probably modified your interface. Wrong answer for one of the public test cases and correct for all public cases, but we don't disclose any information on the secret test data until the deadline. So the grading, as I mentioned earlier, the binary grading is a bit harsh, especially for beginners. So we thought about, why don't we count correct tests? versus all tests and multiply that, that works out. But there are some tests that are harder than others or more important. So we decided to make it a bit better by introducing annotations. If you consider a loop where you, instead of less than n, less or equal, that happens a lot in the beginning. So we didn't want to punish that too much. So we added annotations. Here's an example. So you specify first the exercises, how many points give that exercise, and then for each JUnit test case, you have the normal test annotation, and in addition you have a points annotation, which relates to the exercise, a bonus value, and a comment if you want to. And you also can add a malus value. The difference between bonus and malus is here, you get the points if you succeed in the test, or we reduce the number of points if you fail in a test. Why do we need the malus? If you consider the following code, which checks if an element is member of a data structure, a list or so, and the skeleton looks like this, return true. That's already correct in 50% of the cases. So we didn't want students to cheat by using that. So we decided to add tests that check if students give the same answer for every test case or almost every test case, we reduce the number of points they get. That, of course, doesn't catch stuff like return random next Boolean or stuff like that. But usually, students who try that are smart enough to solve the problem, the real problem. So we don't care that much. In some exercises, you can cheat by using the Java API. So there's a lot of code in the API, and you can use that. So we decided we need a mechanism to forbid stuff from the API, and that's our forbidden and not forbidden annotation. That's essentially a prefix of the classes or methods. You can even forbid single methods in the API, and the prefixes in not forbidden have preference. So you can exclude all from Java util and, wrong example, but you can include it later on single method. So you only may use one single method from that. We forbid by default the reflection API. So with the reflection API, you can work around, again, the restrictions. So we decided that's default forbidden. If you don't like it, override it. One problem is that we didn't want to punish students twice. So consider this code. We have the same isMember function. The student didn't want to implement that or didn't know how to do it. And that member function is called here as part of the source code. So if there's an error in the member function, he will not get the points for the member function, but he will also not get the points for that function as well. So we decided we must handle that case a bit more fair. And the idea we had is to replace the student code. So for some test cases, we replaced the isMember implementation by our own implementation that is correct. And we tested with the mixed source code. So some methods from the student, some methods from us. So we had this replace annotation, which specifies which methods for this test case are used from our cleanroom solution. And we thought, hey, that's a perfect use case for AspectJ. And we first implemented it with AspectJ, but it was way too slow. We even found a 100 times optimization, and it was still way too slow. So we decided to create source code mixes. So we, as I work in compiler construction, we create the syntax tree and change the elements of the syntax tree, create a new source code mix, and pretty print the syntax tree to new source code and compile that. So that was much faster than the AspectJ variant. Funny anecdote on this, that we even found a bug in JavaC's pretty printer by doing that. So, or a student found it, to be honest. So a student wrote code and the pretty printer couldn't handle it. That was a funny experience.
Do you have any sense of why that AOP from AspectJ was so poorly performed?
Yeah, we had to switch during runtime which method was used, our method or their method. So the way was one indirection for each method call. So if you have a method that is called oftentimes, you have this indirection all the time, and the hash map lookup to check which method is really called. So we also run the JUnit test case in stage 2 multiple times. That's because test methods can have side effects. For example, if a student writes a loop, an endless loop, that thread hangs until the JVM ends. The JVM has no option to kill a thread. And that influences further test cases because one core is occupied. And if you have 4 cores on the machine, then you occupy 4 cores with 4 endless loops, and for the next test case, you don't have computing power left. So other problem is global state. If you have static variables and play around with static variables, you have changed the state from test case to test case. So we decided to rerun the test in new JVMs for each JUnit test case in stage 2. And we first try to run the original student code, and if that fails, the mixed version. And we generate JSONs out of this and merge that together to find the best possible result for the student. If the mixed version also fails, we show the student the original error. Because if it still fails and we show the student an error in line, say 100, and there's no line 100 in the student source code, they don't understand what's happening. So this is how it looks for the students. So you have the exercises, and some test cases pass, others fail, and in case of a failure, you see the message. Here in this case, they need the data type. So the person who wrote the JUnit test case even specified you need long here instead of int. And we try to find out by inspecting the call stack a good line which helps the students to show. So if we have a null pointer exception, for example, in our code, we go down the stack to the student's code and show them here is the cause of your mistake. There are some tricky cases when replacing, for example, variable names in both versions of the source code may collide. So that would give a compile error. So we decided we only include variables from our solutions if they are prefixed, and all other variables from our source code are dropped. And we replace that prefix with a more fancy prefix during compilation, so students cannot use __ clean to get a compile error on our side. Yeah. There are some limitations. I showed you this picture earlier. For example, if you have graphical exercises and so on. It's much more difficult to handle with JUnit test cases, but you can fix that usually with standard mock-up techniques or introducing an interface in between and replacing the graphical user interface with your own non-graphic implementation for the JUnit test case. Sometimes we have exercises where we want the students to use recursion. So it's mandatory that you solve this problem via recursion. So we know there's a solution with a loop, but you should learn recursion. So that's mandatory. That's quite difficult to check. So we decided most often that we have a method that they have to call in the base case. And in that method, we inspect the call stack and see, okay, there are multiple instances of that method that looks like recursion. Yeah, and then we had low-level stuff. We had one exercise where they essentially had to implement multiplication in an efficient way, but without using the multiplication operator, of course. You cannot check that in JUnit. So we first checked it automatically, and then the student assistants just did a quick search for the multiplication operator in the code and checked, okay, it's all right. We take the result from the automatic evaluation, otherwise they reduce the number of points. Some interesting numbers. We have per semester around 650 students submitting. We run 7 judge daemons on an 8-core VM. That's way more than we need. Sometimes we have mistakes in our code or in our test cases, and then we have to rejudge everything. And then we need the full judging power. But in the usual day-to-day, we don't need 7 judge daemons, but it's a VM anyway, so it doesn't cost us much. So the sum of all timeouts has to be 60 seconds, so you have to specify for each JUnit test method a timeout, and you don't have to go over 60 seconds, so it doesn't take too long. Total runtime per submission is around 5 minutes if you use really 60 seconds, because we judge it first in stage 1, then in stage 2, 2 times, and each run in an own JVM. So that takes around 5 minutes, but doesn't hurt, because usually the student gets a result after 30 seconds or so for the stage 1, and that's the most interesting part. We used the system for 2 years now. We judged 500,000 of submissions. That also helped a lot to find some bugs in the judge daemon and the sandbox, and yeah. And that means we have approximately 6 submissions per exercise in student. That shows how often a student tries to improve his code. And yeah, that's also a funny number. We ran in a couple of restrictions on our machine. So we used all of the inodes, we used all of the disk space, and we had to learn how to clean up all the stuff. So we didn't run in these stuff, yeah. Yeah, and then nice graphic. Students have 10 days to complete the exercise, and that shows when we get submissions, and you can see in the beginning no one is working, and then they start working during the days, and before the deadline there is no night. That was quite funny to see. Yeah, we have some future work in DomJudge. Thijs is adding OpenID authentication. We want to make DomJudge more cloud ready, so that you can use DomJudge in the cloud and it scales automatically. We are not at the point yet, but we try to do so. For our online judge, we would love to have automated feedback. So if a student fails on that test case, send him back the test case, because if he fails on that test case that is so simple, send it back to him, or if he fails 3 times or something like that. So we reduce further the amount for us. Yeah, and for AutoScore, we try to implement a percentage of points. So if you have a long test case and there's a problem in between, we want to give the students half of the point or something like that. Currently we try to use it for parallel programming. We use Scala for that. And yeah, we have a system we try this semester set up for Scala, but we don't check the parallel part of it. With the system, we only check serial correctness, and if it's serial correct, then the student assistant can check if it's properly parallelized. But we only check serial correctness. And we are implementing currently a what-if interface. The what-if interface means after the deadline, if I want to know if I change that less to a less equal, would I get more points? Yes, you would. And so after the deadline, we allow students to submit again and to see what is really the mistake in my source code. It doesn't affect the points, but it helps the students to realize, okay, I only have to change that line and I would get full points. Yeah, I recommend to try it at home, all of them. Yeah, we have DomJudge, that's the main message, try DomJudge at home. We have a live demo at our website. We have a live image which you can download and start in your computer or virtual machine. You can contribute to the source code, so please send us feature requests or patches. Please also use the other tools that are great and that help in producing high quality problems.